Hello everyone, welcome back to my channel. In this video, we will discuss about that today's problem of the day. That's name is minimum element in BST. Okay, so let us discuss about that problem statement. So you have to be given the root of a binary search tree, and your task is to find the minimum value element in this given BST. First of all, I will introduce about that a small introduction for that BST. Means of that, what does it means of the BST? BST means of that BST means of that I'm just explaining you. This is a binary search tree. This is a binary search search tree. Okay, and uh, what does its property like that? The root left value, the root left value I'm just is always less than root value. Okay, and root value is always less than root right value. Okay, so this is the property of that binary search tree. Okay, means of that I'm just explaining that with the diagram. So suppose this is your value like 5. Okay, so their left value must or be always contain the lower value than compared to the root. Okay, and their right value is always contain the maximum value, like 6 or 7, whatever what you want to make. Okay, so this is the the binary search tree property which is exist into this scenario. I hope you have to be understood about it. Okay, so now how you can solve this problem? So you have to be given that basic example. I'm just like declaring here. This is your basic example. Like you have to be find the minimum value of this given binary search tree. So you have to be, I'm just already explaining you that minimum value will exist that root left side always. Okay, and because of that their right side is always greater than the value of the root. Okay, suppose of that this is value of root, this is the root value, and their right value will always greater than the 5. I hope you have to be able to understand that what I am trying to say you. Okay, so when you will move on their left side, so you will getting that their lower value. Okay, then again you will check that if their left value is exist or not. If it is exist, means of that their minimum value will exist into this given binary search tree. I hope you have to be able to understand. Means of that 5 is greater than 4, just like its basic scenario, and 4 is greater than 3. Because why? Because this is existing into their left side. Okay, so now we have to move on that 3, the so we have to be traverse their left side of this root of this node. So if it is exist, so means of that this value, so that means is that their minimum value is exist into this binary search tree. Okay, so this is the node which is exist into this given BST. And again when we have to be reach on this node, then again we will check that their left side is exist not, because why? Because they have getting a null, and they have getting a null. So this is nothing, their left side is nothing exists, so we will declare this root value, this temporary value. I hope you have to be exist, or we have to be I'm just able to understand you what I'm trying to say. Okay, this value will be returned. Okay, so this is our final value. Again, now we have to be check that second example. So in this example, 9 is exist, 9 is exist, and their right side is 10, and their right side is 11. I hope you have to be understood. And their right side is 10, so means of that this is the maximum value of their 9. Okay, and all other value of in their right side is always greater than the 9. So means of that this value is the minimum value of this whole scenario, of this whole BST. Okay, so your output is 9. I hope you have, this is a very simple problem. You have to be able to understand it what I'm trying to say you. And I have to be and this is how you would be traverse for this binary search tree. We have to be moved by the loop, by the while loop. Okay, so their time complexity, when we will discuss about that, the time complexity. So their time complexity is that, so time complexity, so their time complexity is that order of height of binary search tree. Why? Because of that we will move only those part which have to be their height, according to their height. Okay, according to their height. And when we will discuss about the space complexity, so the space complexity is that constant space. Why? Because we have to be take only one variable, which is a time, to traverse this node to this whole of this binary search tree. Okay, otherwise you cannot be getting as per your choice. Okay, but I am getting that like a node temp, which is a variable to store the node root value, to store the root value. Okay, this is the root value. uh, Sorry, so this is value of root. I hope you have to be understood the approach. Okay, if it is helpful, so please like my video, please subscribe my channel. And this is a solution of C++. First of all, we will discuss about that the basic scenario. If it is root is null, so we will definitely return -1, because nothing will be exist. Okay, and again we have to be move on traversing this left side. Okay, if it is exist or not. If it is exist, so we have to be move on that their left side. Okay, otherwise we will return their data. Okay, if it is, if their left side is not exist. So this is a solution of C++. Here is the solution of Java. Nothing will be changes except the syntax. Okay, so this is working fine. You can check that. And if it is helpful for you, please share my video. Please comment on my channel if you have any of the doubt. Okay, and please write, please comment on this that what type of topic you have to be getting the video by me. Okay, so this is compiling and this is successfully executed. So please subscribe. Because of that, I want to be getting that more energetic and more powerful videos I will share in my YouTube channel. Okay, I am not being a promoted as per side, but I want to get some so this is having some connection issue, but it is existing. This is a C++ solution. This is working fine. Okay, so if you have any doubts, so please like my please comment my channel. Okay, thank you so much.